Good morning children. Today we are performing experiment number 3, which is to find out the focal length of concave mirror. Okay, this is the first part of this experiment where we are going to find out the focal length by using a concave mirror. In the next part we are going to find out the focal length by using a convex lens. Now see the children, this is what a concave mirror, and if you see, this surface is called as a reflecting surface, from where whenever if we placed an object in front of this concave mirror, the reflection will take place on the same side and it will get the focal length. Okay, here the object that we have taken is a candle. Okay, the object that we have taken is what? A candle. Now see, this is the screen. This is what? The screen over which we are getting the image. Okay, now in this experiment what we did that the screen is it is fixed at one point. Okay, it is fixed one, and now in this experiment we are going to move this mirror simultaneously with this candle, which is an object. Okay, when we move this mirror as well as a candle, you will get a sharp image on the screen. Okay, so then we'll find out the distance, at which distance we have placed a mirror as well as an object, and then we'll take a difference between these two, the mirror and an object distance, so that whatever we are getting the image on a screen, that should be a very fine one. Okay, let's do the experiment. Now see, the concave mirror is fixed, and if you measure the distance, it is fixed on the optical bench. The instrument is on an optical bench. If you measure the distance, so I have kept this mirror, this concave mirror at nearly at 84. Okay, it is 84. Nearly it is 84 centimeter. Okay, so it is from the screen, because screen is fixed now, and from the screen it is placed at 84. Now we'll check where you will get the image. Okay, where you will get the image. So you are getting the image on the screen. Look children, this is what the reflection is taking place from this concave mirror, and the image is getting on a screen which is already fixed. And if you see the image, see, it is real and inverted image you are getting on a screen. Okay, so this is what the experiment, that whenever if we have placed any of an object, so we have taken an object which is a candle one. Okay, and when we kept this candle in front of the reflecting surface of a concave mirror, we are getting the image on the same side on a screen, and the image is what? A real and inverted. Then we'll find out what is the distance. So we know that the distance between that screen and the concave mirror is what? It is 84 centimeter. Then we'll find out what is the distance between the screen and the object that we have placed. Okay, object that we have placed. And see, this is what? This is what? To measure the distance, I am using a scale over here. And the distance from the screen to this object is around, it is 62.5. It is 62.5. Okay, so that I have to note down that the distance from the object to the screen is 62.5. Okay, and we have calculated the distance from the mirror to the screen, it is 84. So then we'll take a difference between this 84 minus 62.5, and it will give the focal length. Okay, so this is the first reading. Now children, the next part of this experiment is of convex lens. We are again find out the focal length of the convex lens. Okay, so this is the convex lens. Look, okay, there is a difference between the convex lens and concave mirror. In the first part, we have taken a concave mirror, and if you compare this concave mirror with the convex lens, see, this is only having the front face, it is reflecting one, and the back is polished. But if you take a convex lens, so on both the side, on both the surfaces, okay, this is totally transparent. Look, it is totally transparent, okay. Now, what we have placed? We have kept an object over here. Look, this is the object, okay. This is the object, okay. So I have placed a candle in front of a convex lens, and you are getting its reflection on the opposite of a lens, that is on a wall, okay. This is the experiment, that if we keep this object over at this distance, so you are getting an image on the screen on the opposite side of the lens, okay. And if you look on the image is inverted one, so it proves that wherever we are getting the position of an image on the lens, on the screen, okay, that image is inverted and also the real image by using a convex lens. Now, how to find out the focal length? Okay, how to find out the focal length of this convex lens? Now, for that, you have to find out a distance from the image where it is getting, it is on the screen, image to the lens, convex lens, and it is around 115 centimeter. It is around 115 centimeter. And if I take a distance from the object where we have placed the object in front of a convex lens, then the object, it is at around 100 centimeter. It is around 100 centimeter. Okay, this is by using a ruler scale. Okay, so this is 100. So if you find out the focal length, so we have to take a difference between these two values, and that values will be, after taking the difference, it is around 15 centimeter. So 15 centimeter will be what? The focal length of the convex lens. So in this way, we have to take 3 readings. We'll take the mean of that 3 readings, and after substituting in the values in the observation table, we'll get the focal length of convex lens.